Okie dokie. Sorry, it's taking me a little moment here to get ready, but here we are. I think we're live. Yeah, checking levels. Everything's looking good. A little adjustment here. Get us in focus. There we go. Hi, welcome back. It's been a while, a couple of weeks, but we're here now. We're working on making asteroids in Haskell. So if this is your first time tuning in, you haven't seen the stream before, let's just show you what the game looks like so far. Go to my project directory. I'm going to execute asteroids. Here's where we are. We got asteroids that spawn in. We got bullets. We've got asteroids that explode into smaller ones. We have a score counter up there. And we have a little bit of randomness in when an asteroid blows up in terms of like the starting velocity for those little asteroids that spawn in. And that sort of thing. So one thing I think I want to work on this week is to fix the timing of like this asteroid spawning. Right now, it's just like on a modulo on the actual like the global elapsed time of the game, which isn't no good. It's kind of like not very sporadic. So I want to make some proper timers and spawn them in. What's that for now? So yeah, that's what we're going to work on, I guess, is probably the timers, and then obviously we'd have to do ship collisions with the asteroids in order to get our kind of game over screen going. And that'll probably lead into like the different game screens and states and menus, and then we'll be able to wrap up this project pretty soon. So let's get to work. I'm just going to pull out chat here to make sure that I got you. There we go. Yeah. Yeah, so let's see. Here's our code. Source asteroids game. Make sure the levels are good here, by the way. Yeah, things are looking good. Okay. Alrighty doody. So yeah, spawn random asteroid. So that's the function that does it. And this is the guard condition for it. We're taking the game's current time mod like 20, which isn't good. What we really should do is have like a proper timer. And I think that timer should like count. Either we set like a total number of elapsed time to accumulate into this timer, and then like once it reaches a threshold, we can check that in this guard condition, or we introduce a little bit of variance. So we do this check every so often, and there's a percentage chance that we'll spawn a random asteroid at every given check time, which could lead to droughts of new asteroids spawning in. So I like the idea of like a fixed interval. So let's try that and see how that feels. Okay, so timers. We could create a new type for our timer. It's usually a good way to start, or we could just do it in straight up variables in the game state. Let's just make a new type. It shouldn't be too hard. Okay, so this collision box stuff, I'll put it after the collision box stuff, but before the ship. Okay, so what is a timer? Well, it's got to have a start time that we're going to start the timer at. And then later in the game, as the loop is running, we'll take a snapshot of that time. The difference will be how long the elapsed time, right? Timer start. That'll be a float. And let's see, we could store the elapsed time in the timer. But we need a timer duration. Oh, we could do, yeah, we could just do it elapsed. That might be good enough. Okay. So now that we have timer start and elapsed, we need a update timer function. All right, this would take a timer, the current time, if we want to make it a pure function. We'll float some number of seconds, and then we return a new one. All right, okay. So based on this, well, we have kind of a problem with this function. This float is kind of independent of this timer. We're assuming in our use that this float is going to be greater than the timer start in order to calculate the elapsed, i.e. this float will be like a negative 3.2 or negative 2.8 or some other amount. And that is always kind of like monotonically increasing. Yeah, I don't think we need to like really put that in like the time. I think it'll be fine just to like leave that as a comment. That should be fine. Let's just go with this. We got a timer. And the next state of the timer will calculate the elapsed value. It'll be current time. No, sorry, timer start minus the current time and the difference with the timer start of the timer. And then we will return timer where timer elapsed is equal to elapsed. All right, so if I call update timer on a timer where we have our timer start at 0.0, we can initialize, say, timer elapsed at 0.0 as well. And our current time is like 1.2. Then we should have an elapsed of 1.2. All right. We start the timer at 0.2. I have 1.2, then the timer should be 1.0. Time elapsed. 1 second. Okay. So let's see. So now that we have update timer, We calculate the new elapsed. Now for asteroids, we can go into the game state, create a game state, asteroid, spawn timer. This will be a timer. Okay. So then we want to update the spawn timer in the game state. Well, first we're going to need to initialize it. Let's see. We're going to initialize it at current time that we get from the beginning of this initialization. And elapsed will just be 0. In fact, we should probably just make a constructor function for that. Something simple. Do I use this convention anywhere else? Muck. Standard gen is there. I think I use init a lot. Init game state. Init button state. So I'm going to stick with that. And we'll give that a float, returning a timer. Timer with start time and 0.0. And then I can just replace this with timer and current time. And then we don't need that 0.0 just hanging out there. Okay, so we init the timer. Now we need to update the timer in the game loop. And we could do that here. Game state, asteroid spawn timer. And so we have to give the game state asteroid spawn timer and the current time. The current elapsed time, which will be new time, I guess. Let's pull this over to the left a little bit. Here. And this. This isn't too bad. Okay. So let's introduce a little debugging to debug tracing just to like check that this is working in our game loop and accumulating the time. I think new time is the right value to use here. Import qualify, debug, trace as debug. And yeah, we'll do it right here. Debug.trace just before we render. Get the game state. Asteroid spawn timer of state prime. All right, record. Curses. Record update syntax is not letting us do this. Let's pull it into a variable. Temporarily. Oh, like this. There we go. Okay. That should be good. Let's get our project building. Okay, we're good there. Let's run it. So you see the timer elapsed accumulating there. Good. $13, $14, and so on. So we should be able to write a check in our guard that could just see how long it's elapsed. Let's get rid of the debug tracing. Yeah, that should be fine. Okay. So now our guard should be when elapsed is greater than a certain amount, like a certain amount of time has passed. And then we should talk about resetting the elapsed time, maybe. Okay. So let's change out truncate, blah, 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 blah. And spawn timer countdown. Spawn timer elapsed. And this is going to take the game state asteroid spawn timer of the game state. Now we haven't defined this function yet. So let's define that now. Be able to go down here. Spawn timer elapsed. Okay, so here I'm just using the good old give it the wrong type trick so that GHC just tells me what it is. I do this a lot on the stream, but if you haven't seen it before, that's what I'm doing. Go bool, and then we can say, we can just put our expression here. So the timer elapsed is greater than or equal to, we should probably put a variable in here. We'll call it, I'll just hard code something in there for now. If it's greater than, I don't know, 10, 15, whatever, something like that. Okay, and where's my type problem there? Here? Yeah. Okay, it's probably just because I need to like put these in brackets instead. Precedence things. Okay, so if I compile and run this now, because we're not resetting the elapsed amount, this is only going to spawn an asteroid once when we reach about 15. So somewhere on the screen. Pow, 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 pow. Oh, we're getting a whole bunch. That's not exactly what we wanted. So that's not quite right. Let me get rid of that debug.trace now. What did we do? So when the length of the game state asteroids is less than our max asteroids, and spawn timer is elapsed, then we get the asteroids, and we figure out which side we're going to spawn from by picking a random number, 0 or 1. 0 we're going to spawn from the sides, and 1 we're going to spawn from the top. So if the spawn side is equal to 0, then we pick this for the position X. Otherwise, we pick something like this for the position X. Same with Y. And then we construct an asteroid vector position an asteroid vector. That's the velocity vector, which we calculate from that way. And we actually spawn that asteroid. And we snock that asteroid onto our asteroids. Put random gen prime in. Did I get ahead of any file changes maybe when I ran the game? So that should only... Oh, I know what's happening. It's because once it gets greater than... Yeah, because we're not resetting the elapsed state. That's what's happening. So this condition is always going to be true after elapse is going to be greater than 15. And this is only going to be true as long as the number of asteroids is less than the max asteroids. So we're going to basically really fill up the list of asteroids right off the bat as quickly as we can until we start destroying some, and then it's going to fill right back up again. So after we spawn an asteroid, we have to update the game state to reset the timer. Asteroid spawn timer. Yeah. So this should be now set to the current, the start here should be set to the current time that we did this at. And reset elapsed to 0. So I'm going to call this reset timer. And we have to give it the current time, which we can get from the game state. I think that one does have it. Game state. Current time of the game state. We take a timer and a float. That's going to be the current time to set it to, and we return a new timer. And that's basically just going to be timer where timer starts is equal to current time, and timer elapsed is equal to 0. Okay, we got some type errors. Let's fix those. We need the current timer. That should be good. Yeah. So we reset the timer, and there we go. Now it should be like once every 15 units, which I think in SDL2 terms is about seconds. All right, there we go. There's our one. We should get another one soon. Here comes another big one. Perfect. Okay. So that makes them spawn in a little bit more in a controlled kind of fashion. Now all we need to do is get rid of this magic number here, and then we have a way of actually controlling the rate at which they spawn. So let's create a variable for that. Let's actually commit this, what we have now, as long as we're good with that. Yeah, that's good. We didn't leave any debug statements and stuff in. Okay, cool. Work in progress commit for this. So we'll add the asteroid spawn timer. Then get rid of that magic number. So let's add a game state variable for that. Let's call it game state asteroid spawn delta. And that'll be a float. That should be delta. And go to end of game state. We got to add it there. And we start off. 15 was okay. Nice and easy. Okay, and let's jump down to our to-do now. Okay. So spawn timer elapsed is going to need this variable. Game state spawn asteroid spawn timer. Let's just pass the whole game state in. We can use record.syntax here. I think I'm starting to feel that a good rule for using record.syntax is to use it only in functions where you're just reading the record fields, but avoid functions where you're doing updates, is my general gist. So if your parameter, game state, your return type, is on the right side of an arrow, don't use record.syntax for that type on the left side. Is the general gist of it. I think that might work pretty well as a rule to avoid the kinds of problems we've been having in this code base and maybe in just Haskell code in general that uses that extension. But let me know what you think, if that's a good rule or not. So anyways, we pull out the game state. Let's pull out the timer. Asteroid spawn timer in. And now we can get rid of this 15 here with game state asteroid spawn delta. Our game should behave exactly as before. No change. But now that that's a variable, we should be able to control it from other parts of the game and do what we need to do with it. And there we go. We got a big asteroid spawn in. Cool. Okay. Let's rebase those together. Add asteroid spawn timer. Asteroids now spawn at a delta time, at an interval specified by the asteroid spawn delta game state variable. Wonderbar. Okay. So we could actually we could mess around with that a little bit. Why not? Say whenever we collide a bullet with an asteroid, we can maybe decrement that interval by a tiny amount. Let's go to our collision code. So our collision results. Yeah, we could do it right here. So we handle the bullet and asteroid collision result. Game state. Asteroid spawn delta. Equals game state asteroid spawn delta of the game state minus, say, 0.2 or 3. Maybe even 0.1. Make it a little bit of slower burn, because those little asteroids are also going to contribute to this. Ooh, 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 ooh. That's a little crazy. Happening way faster than I anticipated. What's happening here? This should only be happening when we get an actual bullet and asteroid collision result. Not working. Handle bullet collision, yeah. So this collects together a list of collision results. Now we have handle collision results. A list of collision results. Oh, I see. Okay, okay. We call this here. And collisions here. So that was spawning in way too fast, I think. So either I'm setting the value to a low value, I'm not decrementing it when a collision actually happens, or this list of collisions is always non-empty. What else could be going on there? Because look at all that. That shouldn't be happening. Let's bring back debug tracing in and see what's going on there. Okay. Let us trace here. And we will show the game state asteroid on delta. Okay. So that should only decrement when an actual bullet collision happens, and only by a little amount. It shouldn't be causing... I'll see it's decrementing every frame regardless of what we're doing, which is why it's spawning in so quickly. That shouldn't be happening. And this should only really be happening even on a given frame, because this bullet and asteroids collision result collects the number of total collisions detected. And the number of collisions detected this frame. So if like 3 collisions happened between bullets and asteroids, and we should only count it once for a bullet and asteroid combination. which we know works to our specs. So this statement here should only be hitting when that's actually happening. If we haven't fired any bullets, it should be not triggering. So I think there's something fishy going on with this code here. Let's add a little debug.trace here. So when we run this, we should only see, as long as we don't fire any bullets, that should be an empty list every frame. But it's not. Is it counting? Is it counting that every frame regardless? And maybe we should check the number of collisions is 0 before, or is greater than 0. Yeah, okay. Yeah, that looks like what's happening here. So we are getting this collision result every time, every frame, even if no collisions have occurred. So we only know that no collisions have occurred because number of collisions will be 0. So this should be conditional on that value there. So we can use an if condition here. If number of calls does not equal 0, then this else unchanged. Okay, so let's get rid of the debug.trace on collisions there. That's kind of expected. Barrel. Sorry. Trigger the execution before. There we go. There we go. Now 15 is right. It's staying the same. We should eventually get another big asteroid spawn in. There it is. If we destroy this one, then it's 14.9. There. All right. So our score is 15 now. Now our spawner time is a little faster. Way too many bullets. We probably want to limit the number of bullets here. Maybe a little more. Now it's down to 12. It's still like feeling a little slow. Not very fast. We could always change our guard condition to add an or there. And say if like we're out of asteroids, we don't have any, then spawn another one in, or spawn 2 or 3 or something. To kind of keep this feeling fast paced. Because even with this spawn timer decreasing delta, not quite fast enough. We could ramp that up a little bit maybe and make it more of an exponential or like logarithmic curve. Where it starts off slow but then like picks up speed. Right now it's pretty linear. Yeah, so we'll have to play around with that a little bit, but that's the general gist of it. So let's remove the debug tracing. Right, work in progress. Decrease the asteroid spawn delta. On collision. An asteroid is destroyed. Decrease the spawn delta a little bit. We could even make that amount a variable as well. That might work pretty well. So then we can like change the amount it decreases by a little bit every time as well. Call it the factor or rate. Actually, now I want to kind of call delta the... Just add a little documentation here. The delta time, the elapsed time interval before spawning a new asteroid. The amount to decrease the spawn delta after spawning after detecting a collision. Bullet collision. Okay. So then our init function, we have to update our init state. Game state, asteroid spawn factor. Started at 0.1. That needs to be lined up. Okay. So I can get rid of that magic number as well. Collision results. So again, then we can do game state, asteroid, spawn, factor. Then we can do game state, asteroid, spawn, factor. If the number of collisions is not equal 0, then a game state, asteroid, spawn, factor of game state, and we'll do like 1.2. We'll say 1.5. Else, leave it the same. Right. So now it should like increase. The more frequently we blow stuff up, the more it decreases the spawn timer by. There we go. Now it's just getting crazy. That factor probably should be a little bit much, and we have to gate it by a certain amount so that it just doesn't fill up so quickly, because it just went instant. Okay, and yeah, spawn delta should never be less than, say, a certain amount, a fixed amount. Let's compare the game state. I'm going to pull it out here because I'm going to use it a bunch. Spawn factor. Okay, so we're going to compare the spawn factor to, let's say, our floor. Not spawn factor, delta. We don't have to compare. Actually, we can just do a min. Or max. Max. Yeah, that's probably better. Let's call it next. How do I want to write this? And like our floor delta should be like maybe every 2. Or maybe even every 1 second. Okay. That should be a little better. Love these asteroids. Our spawn factor should be pretty low. That's feeling a little better. Yeah, it's not just kicking into high gear. Now it's in high gear, but it shouldn't get any faster than this. Ah, ha, ha, ha. Yeah, definitely got to limit the bullets here. But there we go. That's feeling pretty good, though. We could maybe do an alert binding here. Next spawn delta. Number calls not equal 0. And game state asteroid spawn delta is greater than or equal to 1.0. This isn't going to be exactly like max because our no. No, let's not get fan. Let's just leave next spawn delta and just pull it out the formula. Max should be fine. We'll just do it with like a little with guards instead of if. Num calls does not equal 0. Otherwise, and we could do the same thing for spawn factor. Feel that there. Next spawn factor. Boom. It's looking a little better. Just line those up. Okay. Let's commit it. Increase spawn factor on bullet collisions. When an asteroid is destroyed, decrease the spawn delta time by... Hey, Swarm Collective, how's it going? Thanks. Welcome back to the stream. Hope you've been well. Increase spawn factor to a minimum delta. Increase the spawn factor by a small factor on every collision. This increases the rate at which we decrease the delta. Yeah, things are going great. Spring is coming around. Snow is melting. And yeah, just having a good time. Okay, so now we have kind of better asteroid timers, spawn timers. We kind of increase the rate at which we spawn asteroids based on how many you've destroyed so far down to a minimum. So the game should feel a little bit more fast-paced. Now we just need to get into ship collisions. And yeah. How should we do that? Well, we're going to need a new collision result. Ship collision. So when we handle a ship collision, what do we do to the game state? Right, we could just set a flag, game over is true. Just restart the game to the initial game state for now. That might just be the easiest way. Can we call init game state in here? Because that's, I think, an impure function, if I'm not mistaken. Yeah. So we could have like a... What do we need to do? Reset game state? Let's just have the flag. Let's just have the game over flag. Just a Boolean. Yes, ship collisions will make the game much, much harder. I'm a big believer in accessibility, so if like I was making like a game, I think it would be a good idea to even consider that in your design. Maybe somebody wants a little bit more of a chill thing. Maybe turn off ship collisions, make it more forgiving. That kind of thing. infinite lives, whatever you want. We're just gonna, for simplicity's sake and scope's sake, we're just gonna make it a Boolean flag, like either the game's over and it's not. In fact, let's not make it a Boolean flag. I don't like using bool. Let's make it a um, game state. Game state? Yeah. What I'm thinking is that we have game status or screen or and we have running or play screen. We could have like a menu state here. We have game state status. Initially in play, probably. That's kind of what we have right now. So in the case where we handle a ship collision, we'll do the game state, but we'll say the game state status equals game over. We have nothing, when we check collisions, we have nothing that actually returns this collision result. We have to do that next. Now, when you're writing a game and you're doing collision detection, this is where you might want a more smarter strategy for doing collision detection. I still think the brute force is going to be fine for our Asteroids game, so I'm probably going to go down that route for ship collisions as well. However, the more game objects you have that are collidable, obviously the amount of objects you have to check against, right, grows really, really quickly. In which case you need strategies to pare down the space in order to like reduce the number of checks you have to make. Right, we're just brute forcing here, so like in check asteroid collisions, we're checking every asteroid again, or every bullet against every asteroid. But we're limiting the number of bullets and asteroids in the game state at a given time, so we know this is like a finite and well-contained number. Same thing with ships. But if you wanted to do more things, walls, tile maps, particles, asteroids, all those kinds of things, then you're probably going to want a smarter strategy here. So how should we do this for ships? Because we're just going to test the ship against all the asteroids and return a collision result. So I'm going to write check ship collisions. All right, that's going to take the player's ship. I think I have a type for that. A deck of asteroids to check against. And then we return a collision result. Such a ship. There it is, just ship. We should probably just call it collision. Check for ship collision. Okay. So here we just need to know if anything is true. So let's convert the asteroids to a list. Extensions dot to list asteroids. Any is ship colliding. And case match on this. Or no, we could just do if. Or we could just do a guard. Any is ship colliding with the asteroids, then we return well, either the ship is colliding or it's not. Maybe we could put that as a maybe collision result. Otherwise, nothing. Does that make sense? It's going to look, I think it might look a little bit weird in our update code, but if it does, we'll refactor it and figure out a better pattern. But let's define is ship colliding. So is ship colliding is going to need, let's just pass it the ship. We get a ship, an asteroid, and we have to return a bool. And we have the bounding box stuff, so this should be pretty straightforward if we have the bounding boxes. Collision box, sorry. Collision box. Right, we have this function is colliding box. It takes 2 boxes. Ship should have one. Has position, has velocity. Okay, we'll need to define one for the ship. And we'll need to, and I think asteroid has one. Asteroid does have one. So then we just need one for the ship. Let's... So it's 2... Oh, shoot. What was the name of the function? It's getting close to the end of the stream. What do we need? Collision box is colliding. Is colliding box, right? Okay, is colliding box. And then our has collision box is get collision box. Okay, so we need is colliding box. All right. And then we can get a collision box of asteroid. And then we just need to get collision box of ship. Let's go implement that instance. Let's collision box ship. Get collision box is our method. Okay, so we're going to need our ship. We have to return a collision box. Okay. So our ship position we have here is the center of our triangle. So we need to offset our position by a regular amount. So if I bring in my pen, I'll show you what I mean. Where's my epic pen? There we go. Okay. All right, so we got a point here. Our ship is usually drawn like around this point. Pretend it's somewhere in the middle. See if I can do this better. So I got my ship. Our point is like somewhere in the middle-ish. We got to draw a bounding box around this. And that's going to be a little bit tricky. All right, because if we just use this as the bounding box, or the collision box, right, it takes a position and an offset, right? Just kind of like a STL rect. So if we just use the position and give it like a width and a height, it would be like this, say. Right? Which is not quite what we want. All right. So what we can do, without getting into tricky without getting to weird, tricky calculations, to orient this box perfectly around the triangle. Right, because you can imagine, for example, a triangle on an angle diagonal this way. And our triangle is kind of long. Right, our position's here. And what should our hitbox be in this position? Right, our collision setup is kind of built around just boxes. It's not really built around having differently oriented boxes. All right, so we wouldn't draw the bounding box like this, which is what you probably intuitively think you might want to be able to do. All right. So that's the least amount of hit area for this triangle. But that's going to be tricky. What we could do is make it just a square. Or at least maybe a small enough square where it doesn't poke out too much. Which means you'll get away with some overlap, potentially with a rendered line on an asteroid, as long as your hitboxes don't overlap. All right, so like the rendered line of the asteroid might be like over here, but its hitbox, might be like this. And so it would look like you're colliding with it, but not quite this frame until these two boxes overlap. That might be the simplest way to do this, because it's more like aligned bounding boxes. If we're to have like arbitrary polygons or aligned polygons to different shapes, like that's possible with collision detection, but it's just the calculations are just a little bit more tricky, and I want to just keep the scope on this pretty small. So I think that's pretty reasonable. Thanks, Swarm Collective, for agreeing with me. So let's do that. Yeah, and it's a little bit more forgiving too. Okay, so then if we're going to do a square, then this can be a fixed size. We'll have to like figure a reasonable size. Let's do like 5, 5. We'll come up with like a little rendering function to render our hitbox to kind of tweak those values. But this should be like -5, say. So that the center of our square is around. So this box will be around the position of our ship, kind of in the middle. Okay. So now that should work. Except we have an error in here. Oh, we didn't add the status. Sorry. Game status. Start is playing. Okay. And then the quickest way for us to know that we're hit the game over state, let's just render like something silly. When the game state status is equal to game over, we'll render text. Game over. Well, I don't have when imported. Okay. So now when I run the game and I collide with an asteroid, we should see the game over text displayed somewhere on the screen. Near. Although I don't see it anywhere. Are we... Oh, we didn't add it. That's why. We're missing a part. So we have the function. We're not using it, though. So collecting the ship collision. Fun game is better than precise game, generally speaking. Yeah, I mean, it depends on the kind of player you are, but yes, that is a good rule. There are some games where I would say that, like, that the difference isn't so great, and, like, the fun is being precise. But it's pretty rare. And even then, even in those games, you still make affordances for players. Because, for example, I'm playing this game called Nebulous. I don't know if you've heard of it. But it tries to be, like, quote unquote, a realistic space warfare kind of simulator. Like, if you had ships with engines in space, like rockets, you know, and using Newtonian physics and the actual distances. So it tries to be fairly precise in simulating a bunch of things. But it also isn't that realistic because space is absolutely massive, and I don't know why you would want to fight anything there. Just getting things close enough where a battle makes sense and is interesting. It's pretty rare. Would be pretty rare in space. What am I saying? Who knows? Fun, but fun always trumps everything. Right, so collision results. We need the collision results from colliding the ship, the asteroids, and doing that check. And we handle all of our collisions well. So we need our ship collisions. Total Annihilation was a precise and fun game. However, it was easy to max out the average machine. Right? Yep. True. Min-maxing, you know. A lot of, like, FPSs and fighting games, like, make precision part of the game, and rhythm games and stuff, too. But again, like, I think accessibility is something designers should take into consideration to make it more fun for more people. You know? As I get older, you know, I'm not going to be as twitchy fast as, you know, my nephews and kids I play with, right? Like, they're going to be... So... It's hard to balance those things, but it is something worth considering. All right, so this is where it's going to get a little bit weird. Because we only want to add the ship collision if there is a ship collision. Hmm. How to do this? Well, what did I call the function? Ship collisions? It could be adapted to an eye tracking device. You know, I don't know. How would you, what are you thinking there? That's what, I'm curious. What do you mean by, how would you, what would you be tracking with the eye device? And what would you adapt to it, to that input? You know what I mean? Like you're saying you can detect reaction times from eye tracking devices and like how quickly someone's APM is, something like that. So check ship collision is what I called it. Game state player ship and game state asteroids. So if the ship automatically turned and followed the location where the person was looking, then the ship would automatically fire, then someone with limited mobility would still be able to play. Ah, yes, yes. That would be a very cool feature to have. I was noticing some accessibility features built into Minecraft Dungeons that I thought was interesting. I'm not sure how practical it is, but they added screen reader support, which is common for menus, but it also works during the game as well. So I'm wondering how well that works in practice for people. But I think that's kind of neat that, you know, anything we can add to afford these experiences to more folks is always a plus. And if you permit me a rant a moment, I really kind of really dislike the way modern computing has turned out. Like my first computer was like an Amiga 500, and like I toyed with computers before then even. Um, and computers today are just so much built around like the influences, because they've had decades to grow up under the influences of capitalism and selling things, that they've become really like designed a certain way, if you know what I mean. And while there are a lot of accessibility features built into modern applications, especially with the web and stuff like that, which are good advances, um, the physical accessibility and the physical experience of using a computer still like kind of asks a lot of our bodies, you know? I spend a lot of my time like hunched over these things and staring at glowing screens, and where that somebody else has designed the interface to, and like I have very little say in my experience with using them. Whereas it felt a lot different earlier on in earlier computers, where they didn't do a whole lot unless you programmed them to, or you intentionally installed programs, right? But now they update and change without your permission most of the time, or they force you to change up and update after a while, that kind of thing. And they've just turned into like distraction machines for me, right? Where it's like hard to do something with them without them like going, and losing where you are, or them just notifying you of things that you don't care about at that moment in time. But yeah, I don't know. I kind of have this dream of a computer that like isn't built around a glowing screen and like a keyboard, or you know, and then like all of the other peripherals that have to go in that to make it accessible for someone else, where the computer's more not there, you know, and it bends to our physical needs and mental needs, you know. I don't know. It's kind of hard to explain, but I have influences and ideas where this stuff comes from. I would like more computers like that, and computer games too. Any hoozle. Let's get back on track. Ship collision. We're almost there. We only got a few minutes left. Um, so like, I could like maybe like this kind of gross, hacky, ugly thing, but I could like append onto this another list. Project Oxygen. I'm curious what this is. I gotta look it up. Project Oxygen. What makes a good manager? That's probably not what you're talking about. What if you have a link or something? Okay, cool. If you're curious, the one of my influences is the Screenless project. The Screenless Office. I think this is a super cool art project, and kind of idea of the kind of computer I'm thinking about is definitely based off of this idea here, and like the plea for diversity here. Yeah, this and like other projects like Dynamic Land that bring more physical computing and more communal, more of a communal nature to computing, or it becomes more of like a community type of space. I think that's really cool too. So elements of these things, I think, are like, if they could converge together and build a kind of computing system that is more adaptable, it'd be kind of neat. That's the kind of project I'd pursue if I'd suddenly run into a ton of money and didn't have to work anymore. I'd probably build it. Okay. And synthesizers, because I like that. Making boop, boop, weep, weeps. Anyways, yeah. So we have this shit. We're gonna append something here. We have something, and let's put this in parentheses, ship collision. All right, this function has to turn a collision result into a list. Or maybe collision results into a list. Maybe two lists. I think that we have that in data maybe. Yeah, maybe two lists. So if I just import data.maybe for that. I'll just import data. I don't think that'll overlap with anything. There we go. Okay. But now when we collide, it should pick that collision up and handle that collision result. No, no. Still not yet. You're welcome, Swarm Collective. Yeah, it is good stuff. I think it's really cool stuff. Especially since a lot of computers are built these days around, like, almost like a planned obsolescence. You know, people are buying like $4,000, $3,000, at least people who can afford that kind of computer, like Apple computers and stuff, are buying like these $3,000 Facebook machines, you know? That spy on them and get them to buy more stuff they don't need. That's all they're optimized for. Just like a lot of computers are good enough for like most people that are. I think we reached good enough computer for a lot of use cases. The only reason why I think a lot of big computers are needed these days are like gaming, and because like phones keep getting bigger pixels. You know, they take bigger pictures and videos, and so like decoders need bigger hardware to run. But if you think about what the average like non-pro user uses a computer for, they don't, you know, a computer from 10 years ago is going to be just fine. So like keeping those computers alive and working would be also pretty nice. Any users. So either we're not hitting this game status to game over, or this block isn't working at all. Um, let's see here. Update. So we get our ship collision. We append our ship collision to collision results. Like on every frame, whether we get a ship collision or not, which kind of sucks, but it's not that big, so whatever. Update the ship position, next state. Okay, so that becomes state prime, then next state. So it should be switching over to that. Let's get our debugging going. And just make sure that we're actually hitting that thing. Thank you, Swarm Collective, for tuning in, and we'll see you next week, hopefully. Have a good one. I'll be done soon. Oh, what did I do there? Debug. Uh-oh, what did I do? I accidentally messed around with some... Deleted some code I didn't mean to. Oh, yeah. Import qualified debug.trace as debug. Okay, so I want to put that trace in handle collision results. And we're going to put it right here. Debug.trace. Handling, ship collision. Yeah, we can probably change this. In fact, we can probably even change this to cons this onto. There we go, a rebuild. Let's try it out. Okay, so when I overlap with this, I should get a collision event. But it's not getting into there. Okay. So that means our implementation of the has collision box for the ship is off, and we're not actually colliding. So let's update our ship rendering to render out the collision box for the ship. Get the collision box for the ship. Also bring it into scope. Like that. And we can do renderer draw color. We'll set it to something like BG. Set it R. No, that's not quite right. RG. Let's make it blue. And then SDL draw rect. That takes the renderer. And then our SDL rect. And we can use the ship box. The elements of the collision box, at least. Box position, ship box, and collision box. Size of the ship box. But it wants it to be cint. Right. Truncate. Let me see what the type of that function is again. So I fmap into that. Okay, so this is a did I do? Collision box. That should be an SDLP, right? Okay, it's a V2 float. Okay, so yeah, truncating it to an int and then wrapping that in SDLP, I think is what we need to convert it into an SDL box. Or I could just write that as a function. Colliding box rect, call it. Take the elements of it like that. We're going to return an SDL.rectangle where the first element is going to be SDL.p of the truncate on the in the collision box position. And this will be collision box size. But also we have to truncate that, I think. Seant. Well, we do this in a bunch of places. Where did I do it before? From integral. Point x and point y. Input p minus origin. Round. I do truncate there. It can't be float to float. Anyways, we're going to replace this with our collision box rect of shipbox. Colliding box rect tubes, okay. Okay, there we go. Float to sea, and that should be truncated. Yeah. Okay, and then let's fix this type error, and then this should be just. Okay, so that should render our box. Ah. And so we have no box rendering. So it must be our instance. Let's just leave it at ship position. Okay, and we'll try it again. And hopefully this will get us something. Oh, there it is. All right. Yeah, it's just our offset position calculation there. Cool. So we'll tweak with this next week and polish this up. But we have the basics of a game over screen going. And then I guess we'll add, that'll be a nice segue into game state handling. Or not game state handling, but game status, I guess. Switching between screens. Menu screen, play field, that kind of thing. Cool, that was a lot of work. Thanks for following along. That was a lot of fun. And if this is your first time tuning in and you don't know, my usual stream schedule is on Tuesday evenings around 10 after 8 in the Eastern time zone. I do these streams where I work on Haskell projects and kind of learn about Haskell programming and what it's like to work in Haskell as a programming language on practical things. So if you like what you saw, you can follow here on Twitch. If you're watching on YouTube because you're in a different time zone or whatever, that's your preferred medium, then you know what to do there in order to get updates and follow along with these streams. Sometimes I do surprise streams every now and again just for funs. And of course, you can get the code that we have created tonight on the GitHubs. Let's just commit what we have here. Add basic ship collision. And game over. I'm going to push this up, and you can find this on the GitHubs. I'm Agent Ultra on most things, not all the things, but on GitHub, definitely. And this is Asteroids. So the code lies here. So if you want to check it out for yourself, go ahead, get a checkout, start, like it, fork it, whatever. It's all good. It's open source. That's why we're doing this. And yeah. We also have a Discord server with a channel just for this stream, so check out declarative.tv there. And you can find our channel for the stream here. In case between streams you want to talk about your projects or what you saw here and kind of have more one-on-one. I'm always checking that out there, so love to see you on the Discord server. I'm Agent Ultra. This has been a pleasure. May your monads always be free and your types always check, and I'll see you next week. Take care.